let's perform a gate combination to obtain a 4-input NOR. The circuit is a 4-input NOR gate made from logic circuits of various types. Its construction complies with Morgan's laws. Furthermore, we connect the output through a transistor so as not to load the gate too much. This way, we can attack higher power elements from a simple logic gate. Logical theory. The operation of the circuit is very simple. It is a 4-input NOR logic gate, so its output will respond to the table we represent. If we recall Morgan's laws and observe the 4-input NOR function, it can be divided into a product of two inverted sums. We will see inverse of A plus B plus C plus D equals inverse of A plus B times inverse of C plus D. This is the product of two inverted sums. If we talk at a logic level, we see that this is nothing more than two NOR gates where the inputs to each are A, B and C, D. The intermediate product is an AND function. This way we can perform a logical function through a simple combination of gates. Operation. Once we understand the reason for the circuit, we will begin testing it. To do this, we will use the table and check each of the outputs for the respective inputs one by one. We will have logic levels 1 by pressing the respective key. For logic level 0, we will leave the key open, since in a rest situation all inputs are 0 due to the fact that they are all connected to the negative supply through resistors R1, R2, R3 and R4. The circuit. The circuit is a faithful reflection of the logical function it represents. We will have the input levels using the P1, P2, P3, and P4 keys. The outputs of the NOR gates pass to an AND gate made from NAND gates, so we will have a gate of this type followed by another configured as an inverter. The output, which already corresponds to a 4-input NOR gate, attacks the base of a transistor to activate the LED on its collector when the output is a high level 1. Putting it into operation. Before connecting the circuit to the power supply, we must check all connections to avoid possible assembly errors. Above all, we must be careful with the power supply to the integrated circuits and the polarity of the transistor and LED. Experiments. The only point in the circuit that we can modify is the polarization of the transistor to vary the luminous intensity of the LED. To do this, we will change the collector resistance. If we want to reduce the brightness, we will increase its value. We must take into account that we are running on batteries and it is advisable to reduce consumption. U2A and U2B form an AND gate. Therefore, to have 1 at output 4, outputs 11 and 10 must also provide 1. The only option that exists is if inputs 12, 13, 8, and 9 are 0. That is, this will only occur when keys P1 to P4 are not pressed.